Okay, so now we'll move on to the next part of our lesson, stationary points. So write the topic stationary point. So this is again something that you are familiar from your O levels. So a stationary point on a curve is any point where the curve has gradient 0. So a stationary point, what is special about a stationary point? The gradient is basically 0. You can determine whether a stationary point is a local maximum or a local minimum or a point of inflection by looking at the gradient of the curve on either side. Okay. So what do you mean by local maximum means? Local maximum means whether it's a minimum turning point. Okay. And a local minimum means whether it's a minimum point. Why do they use the word local? Do you have any idea? So why do they use the word local? Now sometimes there are some graphs that have several minimum points. Like you have it's not just one turning point. You have several turning points. So then there's you don't learn about it in this book, but you have local maximum and global maximum, which means local means only one particular point. You're only concerned about at that point. Okay, but there might be several maximums in a graph. So then we use the word local to describe about one particular maximum or minimum point. Okay, and the point of inflection, and the point of inflection is not something you've heard of earlier, right? So we'll see what's the point of inflection by looking at these rules. Okay, so look at this. Any curve, any point on the curve y equal fx where f dash x equals 0 is called a stationary point. Okay, so now look at this. They have made a table here and they have given you, they have described how the gradient behaves just before the stationary point and just after the stationary point. Are you with me? Now look at this. The f dash x equals 0 means that's the point where you have the stationary point. Can you see they have taken here f dash x minus h? What do you mean by x minus h? X minus h means a little bit before the turning point. Okay, a few x values, a few points before your turning point, and fx plus h means what? A little bit after your turning point. Now, for example, here you can see this point A. I think they're talking here about point A. Look at point A. In this point, at point A, definitely the gradient is 0. At point A is a stationary point. Do you see it's a local maximum? Can everyone see it's a local maximum? Okay, so now what you need to do is, at this point, can you see just before this point, let's take a point behind A. Take a point behind A. And what do you notice about the gradient? What do you notice about the gradient for the values behind it? Do you see that the gradients are positive? And then go to the, after passing the turning point, check the gradients after passing the turning point. Do you see these gradients? They are negative. Do you see? So just before the turning point, you have a positive gradient. At the turning point, you have 0 gradient. And after the turning point, you have a negative gradient. So do you see it creates the negative shape? Can everyone see this? Look at the other one, local minimum. I think a local minimum is at B. Okay, at point B, what happens? At the turning point, the gradient is 0. Okay, so a little bit behind, before the turning point, what kind of gradient is this? Is it positive or negative? I think you can clearly see it's negative. Do you see it's negative? So it comes down. And then at point B, the gradient is 0, which means you are parallel to the x-axis. And then do you see just after the turning point, which way do we have the gradients? Can you see the straight lines? When the straight line goes like this, it's a positive gradient. When your straight line goes down like this, it's a negative gradient. So you can see just before the point B, you have positive gradient. Just after point B, just before point B, you have negative gradient. Just after point B, you have positive gradient. So do you see the minimum shape here? Can you see the minimum shape here? It's a minimum. Okay, so then now we'll discuss about this thing called the point of inflection. Look at a point of inflection. What is the difference in between a point of inflection? Now, can you look at this point O? At the point O, this is the origin. Okay, so at a point of inflection, children, what happens is, now when the gradient is 0, basically your tangent, your curve becomes parallel to the x-axis, right? So in a point of inflection, let me draw and show you. Okay, so this is something called the point of inflection. This point, look at this point. In this point, do you see that at this particular point, we say the gradient is 0, because you can see the tangent will be parallel to the x-axis. At this point, the tangent is parallel to the x-axis. Okay, and then just before the gradient, what kind of a gradient are we seeing? Positive or negative? This is positive gradient, right? Do you see your gradient sign, the increasing sign? And just after the graph, what kind of gradients do you see? Positive or negative? They're positive. So can you see, for point of inflection at the turning point, gradient is 0, but before gradient is positive and after gradient is also positive. Do you see? And also you can even have it the other way. Do you see in this, in the example they have given, just before the turning points, your gradients are negative, right? And at this point, this is the point of inflection. The gradient is 0. And just after also, do you see it's negative? So do you see before the turning point also it's negative, after also it's negative. That means you don't make a proper turning point. Do you make a proper turn? No, you're not making a turn. You come as if you're making a turn, but then you again continue down the same point. You don't make a turn and go back. Do you see? You come as if you're trying to make a turn, making the gradient 0, but then you don't go up. You just go down again. Okay, so these kinds of points are called what? Points of inflection. So in point of inflection, you don't have a maximum or minimum. However, the gradient is 0. However, the gradient is 0. Okay, so let's make a note of this particular rule. Make a note of this particular. Okay, so now we'll move on to the next part. They say in some cases, you can use a second derivative. The second derivative means what? Now, when you differentiate once, we say f dash x. Second derivative means, can you see f double dash? It means you differentiate your f dash again. You differentiate your f dash x again to create the f double dash. So they say in some cases, you can use a second derivative f double dash x to determine the nature of a stationary point. What do you mean by the nature? Now, what are the natures of our stationary points? We have maximums, we have minimums, and we have point of inflection. Those are the three we have, right? So then we can use the second derivative to determine the nature, whether it's a minimum or whether it's a maximum or whether it's a point of inflection. So look at this. If a function fx has a stationary point when x equal a, then if double dash a is greater than 0, the point is a local minimum. What do you mean? You go for the second derivative and you substitute the x value at your stationary point. Now you have a stationary point and say you have the x value, some x value you got for your stationary point. So what you do is you differentiate your f dash x again, get f double dash x, and you substitute the x value into the f double dash x equation. You substitute the x value to the f double dash x equation and see whether the answer is positive or whether it's negative. If f double dash x answer is a positive answer, then your point, the point which you found from the first derivative is a minimum. If the f double dash a is less than 0, or if it's negative, your point is a maximum. If f double dash a is equal to 0, the point could be a local minimum or local maximum or point of inflection. You will need to look at the points on either side to determine its nature. Okay. So I think you guys might be having questions here regarding how this is done, right? The best way to explain this is through an example. So what we'll do is we'll do an example and see what they mean with this. Okay. So first make a note of this and then we'll do an example and I'll show you how exactly these rules are used. Okay, so exercise 7B. They are asking you find the least value of the following functions. Least value means find the smaller, find the minimum. Basically, least value means they want you to find the minimum. Okay, so how do we do this one? So anyway, you know, minimum means it's a turning point. Minimum, maximum, they are both stationary points, they're turning points. What do we do? So what I want to do is first get the f dash x. Okay, how do we find the f dash x? Differentiate. What happens? X square differentiation is 2x minus 12. Okay, 2x minus 12. And then to find the stationary point, what do? We need to set our f dash x to 0. Right? First set the f dash x to 0 before you do anything else. First set your f dash x to 0. F dash x equals 0 at turning point. And then put the value of f dash x is 2x minus 12, right? 2x minus 12 equals 0. 2x equals minus 12 goes to the side plus 12, which means x is 12 divided by 2. Is that okay? X is 12 divided by 2, which is x equals 6. So can you see x equals 6 is the stationary point that you are getting. Okay. So basically, in this case, actually, you don't even. I mean, we can go for the second derivative. However, now when you look at this graph itself, you know this is a what type of graph, right? X square plus 12x plus 8, x square minus 12x plus 8 is a what type of graph? You have it's a quadratic, and since it's a plus x square, it's a quadratic minimum graph. Like this is basically how the graph should be like. So then basically the x equals 6 should be the x value at this turning point. Okay, so you don't even need to go for the second derivative to prove that the answer you got is a minimum. It's quite simply you can see because x square is a minimum graph. It's a quadratic minimum graph. Therefore, it's definitely the minimum. Or else now since anyway I want you to get familiar with the second derivative also, right? So shall we use the second derivative? So get the second derivative. You know f dash x is 2x minus 12, right? So f double dash x, differentiate this again. Differentiate 2x minus 12 again. What do you get? You get simply 2, right? And you don't even get a place to substitute the x value. You just get the x value of 2. So basically, what does it mean? It means it's greater than 0. Yeah, if double dash x is greater than 0 means what? So look at the rules. If your second derivative is greater than 0, if your second derivative is greater than 0, then the point is a local minimum. Your point is a local minimum. In this point, I don't have even a place to substitute x because my second derivative comes directly as positive 2. So therefore, it's greater than 0. Therefore, can I have the y value here also? X equals 6. We didn't find our y value. Can you all find the y value when x is 6? When x is 6, get the y value. Fx is x square is 6 square minus 12 times 6 plus 8. How much is it? How much is it? 6 square minus 12 times 6 plus 8. How much? Minus 28. So the y coordinate is minus 28. So basically your turning point is at 6 comma minus 28, right? So you can write since your second derivative is greater than 0, the point 6 comma minus 28 is a minimum. Is a minimum point. It's not a maximum, it's a local minimum point. And the other thing is, I think they are asking you to find the least value. So what is the least value of the function? Least value of the function. Are they asking the x value or the y value? Function means what? The y value, least value of the function. So when you take your graph, what's the lowest value that your y could take? So what's the lowest value that we get from this graph? The least value of the function is minus 28. So that is the answer. Least value of the function should be minus 28. Question number 2, part C. Fx is equal to 6 plus x, 1 minus x. So before you go for differentiation, what's the first thing you must do here? I mean, you must expand the bracket. You cannot differentiate while you have factorized form, okay? So 6 plus x into 1 minus x. 6 into 1 is 6. 6 into minus x is minus 6x. X into 1 is 1x. X into minus x is minus x square. So you have fx equals 6 minus 6x plus 1x is minus 5x minus x square. Okay, so now let's get the f dash x. 6 differentiation is 0, minus 5x differentiation is minus 5, minus x square differentiation is 2x. Okay, so then so this is my f dash x. So at the turning point, what happens? Minus 5 minus 2x becomes equal to 0. Basically, you get 2x equals minus 5. And therefore, you get x is minus 5 over 2. Is that okay? Minus 2.5. Can I have the y value as well? The y value. When x is minus 5 over 2, what's the y value? The fx. Fx is 6 plus x. 6 plus x, 1 minus x. How much is it? Yeah, it doesn't matter whether you substitute this or this. Both are the same. 29.75. Okay, so this is the y value. Basically, your turning point. 12.25, sorry. 12.25, right? Check the answer. Is it 12 or 12.25? Check the answer. Yeah, so the answer is 12.25. So turning point coordinates. You can give this answer as an improper fraction. That's okay. 12.25. What's the can I have the turning the improper fraction as 12.25 was? Yeah, so we'll keep it 49 over 4. So x is minus 5 over 2. Y value is 49 over 4. Okay, y value is 49 over 4. So then actually you don't even need to go for the second derivative here because you can see here your fx graph is a what graph? Can you see it's a negative x, it's a quadratic. There's x square here, it's definitely quadratic. And what quadratic? Minus x square means it's a quadratic maximum graph. So you could say this is a quadratic maximum graph. We don't need to go for the second derivative here because it's pretty straightforward, okay? Fx is a quadratic maximum graph. Therefore, minus 5 over 2 comma 49 over 4 is a maximum point because it's a maximum graph. This must be a maximum point, right? And then they want the greatest value of fx. Is that correct? Find the greatest value. So greatest value of fx. The greatest value of your function is what? What's the highest value of your function? How much is? What is the greatest value of your function? It's 49 over 4, right? The 12.25. It's 49 over 4. Okay, so this is the greatest value of your function. You could do it by using the second derivative as well. But since it's a quadratic graph, we don't need to go into that extent. That extent we need to go for the next set of questions that we are doing. Okay, so next we'll move on to question number 3. Find the coordinates of the points where the gradient is 0 on the curves with the given equations. Establish whether these points are local maximum points, local minimum points, or points of inflection in each case. So part A and B are similar to what we did earlier. So therefore I move to part C. Third one, part C, you have y equal x cube minus x square minus x plus 1. So let's get dy by dx, or yeah, because it's y, I'll take dy by dx. Okay, basically f dash x. X cube differentiation is 3x square minus x square differentiation is 2x minus x differentiation is 1 plus 1 differentiation is 0. So at turning point, what happens? At turning point, dy by dx is, at the turning point, dy by dx is equal to 0, right? So then you get here dy by dx is 0, 3x square minus 2x minus 1. I think it's a quadratic equation which factorizes properly, right? What are the two factors? X minus 1 and 3x plus 1. Is this okay? Is this okay? Did you all get this? So then the two x values we have are x minus 1 equals 0 or 3x plus 1 equals 0. We get x equals 1 or 3x equals minus 1, where I basically get x is minus 1 over 3. Is that okay? And then they are asking us to find the coordinates of the point. So coordinates means getting x is not enough. You must also get y. Can you all find the y value? So basically all you have to do is replace the x values onto this y equation. Type the y equation and get the answers. So I get here y equals this is x cube minus x square minus x plus 1. And then calc, and let's give the x value 1. When x is 1, the y value is 0. Do you agree with that? When x is 1, the y value is 0. And when x is minus 1 over 3, what was the y value? When x is minus 1 over 3, 32 over 27. So this is the point. The points are 1, 0 and minus 1 over 3, 32 over 27. These are your 2 points. Now you need to establish which of these points are minimum, which of these points are maximum. So for that, what we do is we go for the second derivative. So you have your dy by dx, which is your f dash x. Okay, so then dy by dx is there, which is 3x square minus 2x minus 1. Go for the second derivative. Second derivative means differentiate twice and we create something called d square y by dx square. Can every one of you see? D square y by dx square is when you differentiate the second time. Okay, or this is in other words the f double dash x. So let's differentiate this guy again. 3x square differentiation is 6x minus 2. Now what do we do? Now you can see this time your second derivative comes in terms of an x. So basically it means because there are two x points on your curve, you need to replace each x value and check whether your second derivative is positive or negative. Okay, so when let's say when x is when x equals 1. So when x equals 1, what do we have? The second derivative becomes d square y by dx square becomes 6 times 1 minus 2. 6 times 1 is 6. 6 minus 2 is 4, right? Second derivative is 4, which is what? Greater than 0 or less than 0? Greater than 0. It's positive. Therefore, what do you have to say about the point 1 comma 0? Therefore, the point 1 comma 0. If your second derivative is positive, it means it's a minimum. So therefore, 1 comma 0 is a minimum point. The local minimum. 1 comma 0 is a local minimum. Okay? Is that part okay? And then you must also check the second derivative when x is what? Minus 1 over 3. You have to check for both the points because one point is a minimum, the other one you have to check it. So the second derivative d square y by dx square. 6 times x is minus 1 over 3 minus 2. How much is the second derivative? 6 into minus 1 over 3 is minus 2 minus 2. It's minus 4, right? You get minus 4, which is what? Which is less than 0. It is less than 0. So if it's less than 0, what does it mean? The point minus 1 over 3 comma 32 over 27 is a maximum point. So that's what it means. Is that okay? Okay, if your second derivative is positive, your point is a minimum. If your second derivative is negative, then the point is a maximum. That's what this rule says. That is what we wrote here. This rule, if your second derivative once is positive, it's a minimum. If your second derivative is a negative, less than 0 means negative. It's a maximum. Okay. Shall we move to the next one? Part D. Y equal x times x square minus 4x minus 3. So can we differentiate when it's in this form? No, first you must what? Expand the bracket. So leave the y as it is and open the bracket. So x cube. So it's x cube minus 4x square minus 3x. Take it to this format and then you differentiate. So let's get dy by dx. Dy by dx gives me 3x square minus 8x minus 3. Is that okay? So at the stationary point, dy by dx is equal to 0, which means 3x square minus 8x minus 3 equals 0. Can I, does it factorize well or do we have to go for the formula? What are the two factors?
X minus 3x plus 1 3. 3x plus 1.
3x plus 1. X minus 3, 3x plus 1. Is that correct? So you have x minus 3 equals 0 or 3x plus 1 equals 0. X equals 3 or x equals minus 1 over 3. And then immediately I want you to get the y values also. Get the y values also. What are the y values when x equals 3? Just
Minus
substitute
18.
x is 3 into this equation. Okay?
Minus 18.
When x is 3, y is minus 18. And when x is minus 1 over 3, y is 14 over 27. Can someone please verify these answers? Do I need, I have to check it from the cal device. Verify these answers. When x is 3, y is minus 18. When x is minus 1 over 3, y is 14 over 27. Is it okay? Yes. Then what we'll do is we'll now confirm whether each point is a local maximum, local minimum, or a point of inflection. Okay, let me check. I think we need to check it. Basically, you type in the cal, right? 3x, what you type in your cal is, you type x cube minus 4x square minus 3x. X cube minus 4x square minus 3. This is your y equation. So first replace x with 3. When x is 3, y is minus 18. And when x is minus 1 over 3, it's 14 over 27. It's correct. These answers are correct. So now let's get the second derivative. What's our first derivative? Dy by dx is 3x square minus 8x minus 3. So differentiate again. D square y by dx square gives us what? 3x square differentiation is 6x minus 8 minus 3 becomes 0, right? Is that okay? So what do we get here? When I had to replace the x values, right? So now when x is 3, so when x is 3, the second derivative d square y by dx square becomes 6 times 3 minus 8. What do we get? 6 times 3 is 18 minus 8. Second derivative is 10, which means it is positive. Positive means what? When x is 3, the point where x is 3 is a minimum point. If your second derivative is minimum, it means it's a positive. It means the turning point is a minimum turning point. So it's going to be 3 comma 18 is a minimum. And then let's do when x equals minus 1 over 3. 3 comma minus 18 is a minimum. Yes, 3 comma minus 18 is a minimum. Okay, then next one when x is equal to minus 1 over 3. So when x is equal to minus 1 over 3, check your second derivative, d square y by dx square. 6 times minus 1 over 3 minus 8 minus 10, which is definitely less than 0, which tells us what? Minus 1 over 3 comma 14 over 27 is a maximum point. Okay, it's a maximum point. Okay, then let's move on to part I. Okay, let's move on to part I. Y equal x to the power 4 minus 12x square. Okay, let's get started with this one. Y equal x to the power 4 minus 12x square. Okay, so we need to get the turning points and decide whether the turning points are minimum or maximum. So get dy by dx. When you get dy by dx, we get here dy by dx equal x to the power 4 gives me 4x to the power 3. 12x square differentiation gives me 24x. Okay, so at the turning point or at the stationary point, your dy by dx becomes equal to 0. So dy by dx is 4x cubed minus 24x equals 0. And then how do we solve this equation? Now, obviously, you can see it's not a normal equation, it's a cubic equation. So we need to factorize it. So how do we factorize it? You can't just take things to the and cut off, take x out. I end up getting here 4x square minus 24. Is that okay? I end up getting here 4x square minus 24. Okay, then what do we do? Let's factorize each person to 0. X equals 0 or 4x square minus 24 equals 0. Let's solve this one. 4x square equals minus 24 becomes plus 24. X square equals 24 divided by 4 is 6. Is that okay? Which means x is equal to what? Plus or minus square root of 6. So do you see how many turning points are there? There are 3 turning points. X equals 0 or x equals to positive root 6 or x equals to negative root 6. There are 3 turning points. For each point, I want you to get the respective y value. Get me the y value for each of these points. Get the y value. So let's substitute the y value, y equation. Let me type. Yeah, when x is 0, it's 0. Yeah. For the root 6, we have, and root 6 and negative root 6, we need to type and see. X to the power 4 minus 12x square, right? X to the power 4 minus 12x square is your y equation. When x is 0, obviously you can see y will be 0. Okay, and then when x is root 6, we get, calculate when x is root 6, we get minus 36. Is that okay? And when x is minus root 6, when x is minus root 6, we again get minus 36. Do you guys agree with this? So there are 3 turning points. The turning points are respectively 0, 0, root 6, minus 36, minus root 6, minus 36. These are your 3 points. Okay, now what you have to do? You have to determine whether each point is a maximum, minimum, or a point of inflection. Okay, how do we do that? Let's get the second derivative. Dy by dx is dy by dx is 4x cubed minus 24x, right? Shall we get the second derivative? The second derivative is d square y by dx square. 4x cube is 12x square. Minus 24x, the differentiation is minus 24. Is that okay? Okay, now let's substitute our x values. You can see there's only x value to be substituted here, right? You can't substitute y values into this equation. Only x values can be substituted. So when x is 0, what happens to the second derivative? D square y by dx square equals 12 times 0 minus 24. I think you can see we get minus 24, which is what? Which is less than 0. So minus 24 is less than 0, which means what? Which means 0, 0 is a what point? 0, 0 is a maximum point. And the next one, when x is root 6. When x is root 6, we get, let's substitute for d square y by dx square. Twelve times root 6 square minus 24. How much is it? 48. 48, which is greater than 0. Therefore, greater than 0 means it's a minimum point. Therefore, root 6, minus 36. Is a minimum point. And I think we can expect the same result when x is minus root 6, because it's x square here. When minus root 6 squares, we should definitely get the same answer. So d square y by dx square should be the same, right? Because minus root 6 and bracket, and you put the square of the whole thing. So it cannot be different, right? Root 6 square and negative root 6 square, I mean, answers are going to be the same. So it cannot be a different answer, right? Which means this is how much? Again, it should be 48. Should be again 48. Okay, be careful when you're squaring. It's x square here. So x is minus root 6. Minus root 6 within bracket and put the square. Okay, otherwise your answer will go wrong. Which is greater than 0. Therefore, minus root 6, 36. Minus root 6, minus 36 is again, it's a minimum. If it's the second derivative is positive, means it's a minimum. It's a minimum point. Okay, is that clear? Okay, fifth one, by considering the gradient on either side of the stationary point of the curve y equal x cubed minus 3x square plus 3x, show that this point is a point of inflection. Okay, and they're asking you to sketch the curve. Okay, first thing, what do? First thing is we write our equation and we differentiate it, right? We write our equation, we differentiate. So I get here dy by dx is x cube differentiation is 3x square. 3x square differentiation is 3 times 2, 6x to the power 1 plus 3x differentiation is 3. Are you guys okay with it? So at stationary point, what happens? At stationary point, what happens? Dy by dx is set to 0. So dy by dx is 3x square minus 6x plus 3 equals 0. So I can divide the whole, it's a quadratic equation. Before you go to solve it with the and show the methods, just remove the multiple. Can divide the whole thing by 3x square minus 2x plus 1 equals 0. Is that correct? I think you can see this is only one answer we get, right? In the calculator, we get x equal 1, which means when you get only one answer in the cal, it means it's a repeated rule. The discriminant is 0 in this case. X minus 1, x minus 1, because only one answer comes. So basically it's x minus 1 square, which gives me the answer x equals 1. So I get only one turning point. Do you see? There is only one turning point. What's the y value? When x is 1, what's the y value? 1 cube minus 3 into 1 square plus 3 into 1. We get y equals, when you replace x with 1 here, we get y equal 1. Type it in the calendar. So your point is 1, 1. The stationary point is 1, 1. Now what do you need to do? Now we need to check whether the stationary point is a local minimum, maximum, or a point of inflection. So what do? We take the first derivative dy by dx and we differentiate it again, right? Are you with me? We differentiate it again. So what do we get here? The second derivative d square y by dx square is 6x minus 6. Okay, 6x minus 6. So then let's substitute x equals 1. When you substitute x equals 1, we get d square y by dx square. This is x equals 1. 6 times 1 minus 6. Answer is 0. The second derivative answer is 0. Can you see? So now what does it mean? Now I gave you the rules in the previous page. So what are the rules? If your second derivative is 0, the point could be a local minimum, it could be a maximum, or it could be a point of inflection. So see, can you see the trouble? Now, if your second derivative is positive, it is solidly a minimum. If your second derivative is negative, your point is definitely a maximum. But however, if your second derivative is 0, do you see we have some uncertainty? Like there is, I mean, it could be anyone. It could be a maximum, minimum, or a point of inflection. So when you come to this case where your second derivative is 0, what do they ask you to do? They ask you to look at the points on either side to determine the nature. That means you remember points on either side to determine the nature. This table where you go a little bit behind the x and where you go a little bit in front of the x and check whether your gradient is positive or negative. And that can help you to determine whether it's a minimum, maximum, or a point of inflection. Do you understand? Take your x value and then go a little bit behind that x value and go a little bit in front. Substitute those x values to which equation? To the y equation. No, to the gradient equation, because you need to check whether the gradient is positive or negative, right? Because if before the turning point, if you have a positive gradient, and after the turning point, if you have a negative gradient, then we end up getting a maximum. If you have before the turning point, if you have a negative gradient, and afterwards, if you have positive, it's a minimum. Do you see? So at a point of inflection, before the turning point and after the turning point, you have both the same type, either both negative gradients or both positive gradients. So this is how we do manually. So in this case, they are asking you, you will need to look at the points on either side to determine the nature, which means you have to do it manually. So whenever your second derivative is 0, to determine whether it's a minimum or a maximum or a point of inflection, you will need to do it manually. Okay. So now you can see we came to the point where we have to do it manually, because why? Our second derivative became 0. So if your second derivative is 0, what does it mean? This point 1, 1 can be a minimum or a maximum or a point of inflection. Are we sure about it? No. I mean, we don't know which one it is. So we have to determine now which one it is. We still don't know. So what do? I told you, let's make a table for gradient, right? So what are the x values we choose? Our turning point x value is 1, right? The turning point x value is 1. Is that clear? So go a little bit behind 1. Let's take x0 and go a little bit after 1. Let's take x value of 2. Are you all with me? Take these x values, make this table. And let's get the what value now? Let's get the dy by dx value, because who is dy by dx? dy by dx is your dy by dx is the gradient, isn't it? This table is to determine the nature. I want to now determine at x equals 1 whether I have a minimum, maximum, or a point of inflection. So I do not know when your second derivative becomes 0. So what you do is first you put x equals 0. Like you can even, it doesn't matter. It doesn't need to be strictly 0. It could be decimals just as long as it's behind 1. So even if you put 0 0.5, 0 0.1, -2, whatever it is, it doesn't matter. As long as it's before 1, and it's better you use a value who is close to 1. Do you get me? Don't go a lot behind. Take a value who is close to 1. So 0, 0 0.5, anything is fine. So a value after 1 is 1.5, anything after 1. Just don't go way too much. Okay, close values to your turning point. Are you with me? This x equal 1 is the turning point or the stationary point. X equal 1 is a stationary point. So we go a little bit behind the stationary point and we go a little bit in front. Can I know the dy by dx value? So what you do is, you take your dy by dx equation, 3x square minus 6x plus 3, right? 3x square minus 6x plus 3 is your dy by dx equation. Am I correct? Yes. Now let's substitute these values. So let me type my dy by dx equation. 3x square minus 6x plus 3. This is my dy by dx equation, the gradient equation. Are you with me? So let me replace it with first x0. When I replace it x0, what kind of answer do I get? I get positive 3 means it's a positive answer, which means gradient is positive. Do you agree? At x equals 1, I should definitely get dy by dx equals what? 0. We don't even need to check. At x equals 1, it should be 0. That's why it's a turning point. At x equals 1, gradient is 0, which means it's neutral. And then the line is parallel to x-axis. And then at x equals 2, calc when x is 2, we get x is 3 again, positive 3, right? So positive 3 means what? The graph is continuing down or up? It continues up because it's a positive gradient. So it should go up. So do you see how the graph goes? At the point 1, 1, what do we have? So on either side of the turning stationary point, I have positive gradient. So that means what? 1, 1 is a 1, 1 is a what? Point of inflection. It's not a minimum or a maximum. It is a point of inflection. Okay, so it's a point of inflection. Then they ask us to also sketch the curve, right? Sketch the curve. So how do we sketch this curve? Now you know there is only one special point, right? Only the 1, 1 is the only point of inflection. So when you're drawing the graph, when you're sketching any curve, the basis is you must always show the place where the graph cuts the x-axis and the y-axis. That's something we do traditionally, right? Can you all please find the place where the graph cuts the x-axis and the y-axis? Y equals, what's the y equation? Y equal x cube minus 3x square plus 3x. So when you cut x-axis, when you cut y-axis, x is 0. So when x is 0, what do you get?
0, 0.
All of these are 0. Yeah, y is 0. So basically, do I need to find the place where we cut x-axis again? If x is 0, when x 0, y becomes 0, then vice versa, when y becomes 0, x should also be 0, right? So that means it cuts the x-axis, y-axis at the 0, 0 point. Do you get me? So then shall we draw the graph? So what happens when you draw the graph? 0, 0 is 1 point. And you know this, you can definitely see the shape of the graph. Do you see? It's supposed to be an increasing graph. Where is the inflection point? At 1, 1, right? Are you guys with me? 1, 1 is the point of inflection. At this point only you have the flat gradient. Okay. So you have the flat gradient here. that looks a little bit different. Something like this. Can you see? So before the graph also the gradient is positive, after the graph also gradient is positive. And you can see the graph passes through the 0, 0 point as well. So it's really important when you're sketching a curve. You must show the place where the graph cuts the x-axis, y-axis, and in this case, the point of inflection also must be clearly marked. Okay, so this is the sketch of the graph. Okay.